Welcome to Practical PyTorch. In this video, you'll install PyTorch and run your first tensor. You'll see the 4 layers that sit under a single line of code. You'll also learn how to ask your own machine what hardware it has. Here's the whole start. Import torch. Make a tensor holding 1, 2, and 3. Then print it and PyTorch shows it back. Tensor 1, 2, 3. So that part is easy. But here's the question nobody answers. What actually sits between the line you type and the chip that runs it? That's what this video is about. This video has 4 parts. First, run it once. Install PyTorch, import it, and make a single tensor. Second, look under one line. The 4 layers your single line of code falls through. Third, ask your machine what hardware it actually has. And fourth, when the build is the bug. The GPU is right there, but PyTorch says no. Let's do the easy part first. Install PyTorch, import it, and make a single tensor. Installing is one line at a shell. Pip install torch, version 2.12.0. PyTorch is a tensor library for Python, so you just import it. And we pin the version, 2.12.0, so you're running the exact same PyTorch we are. Import it, then print the torch version. It prints 2.12.0 plus C, U130. The 2.12.0 is the version. The plus CU130 is the CUDA build. This copy was compiled to drive an NVIDIA GPU. Watch that suffix, because it comes back later. Now make a tensor holding 1, 2, and 3 and multiply it by 2. PyTorch answers right away, tensor 2, 4, 6. Notice you didn't build a graph or compile anything. The multiply ran the instant you typed it. That's eager execution. Each line runs now, just like ordinary Python. Same 2 lines, but on an Apple laptop with no NVIDIA card. The torch version prints 2.12.0 with no plus C, U this time. And x times 2 gives the same answer, 2, 4, 6. So this is the non-CUDA build, and the result is identical. PyTorch reports what your machine has, and the code you write is the same everywhere. You've run a line. Now let's slow down and look at what happens underneath it, one layer at a time. X times 2 looks like one simple step, but it's really the top of a stack of 4 layers, and your line sits right here at the top. The line you type is your job. Everything under it, the next 3 layers, is PyTorch's job, not yours. Let's uncover them one at a time. When x is a tensor, x times 2 doesn't do the multiply itself. It calls one of PyTorch's own operations, torch.mul. Every tensor operator maps to a named op like this one, and it still runs the moment you press enter, which is eager execution again. Under the op sits a dispatcher. Its job is to pick the right code for your device, CPU or CUDA. Notice this box has a dashed border on purpose. We're leaving it closed for now. We open it up in a later video to see how it chooses. At the very bottom is the kernel, the compiled code that actually multiplies the numbers. This is the last layer, the code that runs on the chip our opening question asked about. A tensor on the CPU uses a CPU kernel. A tensor you've moved to an NVIDIA GPU uses a CUDA kernel. Same math, picked by where the tensor lives. A plain tensor lives on the CPU. Devices get their own video soon. Let's put it together. At the top is your line x times 2. It calls a PyTorch op, torch.mul. The dispatcher picks the right code for your device, and a compiled kernel does the actual arithmetic. So one line falls through 4 layers and it runs immediately. The dispatcher is the one box we open later. Keep this picture in mind for the whole course. That's the whole stack, from your line down to the kernel. Now a good question: how do you find out what your machine actually has? 2 lines tell you what your setup can use. Torch.CUDA. Is available asks for an NVIDIA GPU, and here it's true. Torch.backends.mps. Is available asks for an Apple GPU, and here it's false. And torch.CUDA. Get device name even prints the name, a Tesla T4. This free collab box really does have an NVIDIA card, so PyTorch says so. It reports what this machine has. It never assumes. Same 2 lines, different machine. On the Apple laptop, torch.CUDA. Is available is false, since there's no NVIDIA card. And torch.backends.mps. Is available is true, because it has an Apple GPU. Same code, opposite answers because the hardware is different. The machine answered, not your code. MPS is Apple's GPU backend, and the full device story comes in a later video. Now the setup question people ask most. Your GPU is right there, everything looks fine, and PyTorch still says it can't use it. Let's see why. Look at this. NVIDIA SMI shows a real Tesla T4 sitting in the machine, but the Torch version prints 2.12.0 plus CPU, and torch.CUDA. Is available says false. But notice, you installed the CPU-only build. It was never compiled with CUDA, so it can't use an NVIDIA GPU. The clue is the version. It ends in plus CPU, not plus C, U130. Reinstall the CUDA build and the same line returns true. Your turn. There's a GPU in the machine and the driver is fine, and yet torch.CUDA. Is available comes back false. Why? Pause the video and guess. Okay, here it is. It's the build, not the machine. You installed the CPU-only build, which has no CUDA inside it, so it can never use the GPU. Reinstall the CUDA build and it works. Let's recap. PyTorch is a tensor library and it runs your line right now. That's eager execution. One line falls through 4 layers, ending in a compiled kernel. Ask the machine what it has with torch.CUDA. Is available. Don't assume. And if the GPU is there but ignored, the build is usually the bug. A CPU-only build can't use it. You can install PyTorch, run it, and see what your machine has. Next, we look at the thing every line acts on, the tensor. It's a grid of numbers with a shape and a D-type, and almost every bug you'll hit is one of those 2 being wrong. See you in the next video.